Today we're going to learn how to classify matter according to elements, compounds, and mixtures. Our essential question for the day is, how is matter classified based on its composition? What is matter? Well, matter is anything that has mass and takes up space. Using that definition, decide which of the following is matter, put a yes next to those, and which ones are not matter, cross out those. Now, air does have mass and it does take up space, so it is matter. Bacteria also has mass and takes up space. It is also matter. Magnetism, however, does not have mass or take up space, so it is not matter. The stars each have mass and take up space, so they are matter. Light does not have mass and does not take up space. You can't touch it, so it is not matter. Energy is not matter as well. However, let's look at question 2. What is a pure substance? Well, pure substances are made of the same material throughout and have the same properties throughout. We will be learning more about physical and chemical properties next week. For now, know that density, melting point, and malleability are all physical properties. Chemical properties include reactivity, flammability, and acidity. Basically, physical properties are physical characteristics that do not change when they are measured. They might depend on the amount of something you have. Chemical properties are always the same for a given substance, no matter how much you have. However, some change occurs in order for you to measure these properties. For example, to measure the flammability, you have to actually set it on fire and convert that substance from the given chemical to a different substance. An easy way to decide if something is a pure substance or not is to pretend like you are holding it in your hand. Ask yourself if what you have is just a single kind of a substance. So, is it all made of the same thing? Now, let's consider the simplest form of pure matter, or the simplest pure substance. Elements. Elements are the purest form of matter which cannot be broken down. Any amount of a pure element will retain its unique physical and chemical properties for that element. There are 118 of these elements, each of which are represented on the periodic table. Chemical symbols on the periodic table are always one or two letters. However, only the first letter will be capitalized. So, for example, S is capital. In Mg, M is capitalized, but G is not. If you look on the periodic table, S is sulfur, and capital M lowercase g is magnesium. Now, pause the video and try the do section. Write the name of each element represented by the chemical symbol given. Topic question 4 is, what is a diatomic element? Well, di means two and atomic means atoms, so diatomic means two atoms. A diatomic element is an element which in its pure form is always bonded to itself, sort of like twins that are always together. So as an example, iodine, I, is never found as a single atom. It's always found as a molecule made up of two iodine atoms. There are 7 of these diatomic elements in all. There's a kind of mean and totally not true mnemonic device to remember these. I have no bright or clever friends. Another way to remember it is that those elements make a 7 on the periodic table because there are 7 of them. And of course, hydrogen is always the weirdo. So, I is iodine, have is hydrogen, no is nitrogen, bright is bromine, or is oxygen, clever is chlorine, and friends is fluorine. Make sure you complete the mnemonic device on your page. Topic question 5 is what is matter that is composed of more than one element? Well, compounds are pure substances that are made of two or more elements that are chemically bonded together. So, a compound has different properties than its individual elements. For example, chlorine gas is mustard gas. It is very toxic. Sodium is a very explosive metal that will react readily with water and explode. However, when these two chemically combine, they make NaCl, which is table salt, which we eat every day. Now, in order to form or break up compounds, energy must be taken in or given off. Separating the elements in a compound always requires a chemical reaction. Now, what are some things that indicate that a chemical reaction is happening in the speaker? Well, there's a color change, there's bubbles, there's temperature increase, there's a vapor, so all sorts of things. All of these are indications of chemical reactions. Just like elements are given by chemical symbols, compounds are given by chemical formulas. Chemical formulas represent how many atoms of each element are part of the compound. So, I want you to circle each element symbol with a different color in the chemical formulas. For example, I circled carbon with purple in carbon, circled oxygen with red. On the other hand, we have calcium carbonate, which is what seashells are made out of. Now, I circled calcium with yellow, carbon with purple, and oxygen with red. Notice how each new element symbol always starts with a capital letter. So, if you count the number of capitals, you'll know how many elements make up that compound. Here are some other examples, including water, baking soda, sugar, and table salt. I'd like you to pause the video and try the do section. Make sure you circle all the individual elements. Let's look at topic question 6. What is matter that is composed of more than one substance? Well, we call that a mixture. Mixtures are not pure substances. Their parts are not chemically combined, they are only physically combined, which means to separate them, we don't have to have a chemical reaction. We simply physically separate them, or separate them according to their physical properties. When substances are combined into a mixture, they keep their own properties because a new substance has not been formed. So there's two types of mixtures. One is homogeneous, the other is heterogeneous. Homogeneous mixtures are where the parts are evenly mixed and they stay evenly mixed. So you cannot see the individual parts of a homogeneous mixture. We also call these solutions. For example, air is a solution of gases, brass is a solution of copper and zinc metals, and tea is a mixture of sugar and water, as well as some flavoring. Heterogeneous mixtures, on the other hand, have the parts unevenly mixed. So these are things like a chunky soup, And in this case, there are two different types of heterogeneous mixtures. One is a suspension where the particles are all kind of mixed together, but if you set them out, they'll settle down over time and form layers. That's why whenever you try to open your ketchup bottle, there's always a watery layer on top. Another example is a colloid, which is where the particles can be seen in a beam of light. So colloids are kind of dispersed throughout, but they stay that way. You don't have to shake up your milk every time you use it. Now, our final question is, what are similarities and differences between elements, compounds, and mixtures? I've actually filled in part of your Venn diagram, and I'd like you to complete what I've written using your notes for sections 1 through 6. This will show the similarities and differences between elements, compounds, and mixtures. Pause now. Finally, I want you to look at your page and try the Sum It Up questions. When you are done, make sure you check in with me and check your answers.